Now that we have our time equation, which we are going to attempt to minimize, we need to first consider what the domain is for x. Because this equation, who knows what its actual domain is? We've got square roots up in here. We've got a linear part that's over here. Actually, as it comes right down to it, I think it's all real numbers because you can put anything that you want in here for x. You could square it, add 9 to it. It's still going to be a positive number that you can take the square root of. But are all of those values of x valid? Do they make sense within the context of this problem? No, they do not. So we need to make an important consideration for what the domain is for this particular problem. And our domain, it depends on x. Of course, domain has to do with x. But what is x? In this case, what is x? Let's look at the picture. X is the distance along the bank where this bug is going to land their boat right here, right? So that is x. We want to know what is the smallest possible value for x and what is the biggest possible value for x. Our x, the smallest possible is going to be 0. If x was equal to 0, where does the bug land their boat? Lands it right here at point C. You just go straight across. There's your x. X is equal to 0. Can it be equal to 0, or is it supposed to be like greater than 0? In this case, it can be equal to 0, and you land directly on point C. What's the biggest that x can possibly be? Well, that is if you stay in your boat the whole entire time and go all the way downstream to point B. And that means that you're going to land your boat straight down here at point B, where x is equal to 8. 8 kilometers, that's right down there, right? So those are our two values that vary in between 0 and 8. It can be equal to 0, it can be equal to 8. Look at that, we have ourselves a closed interval. So from 0 to 8. Now, just to be clear, this 0 right here, it means that you land, we'll see, you land at point C. And this 8 here means that you land the boat, not you, but the bug, land at point, what was it, B? Yeah, there you go. All right, and we have a closed interval, which means that we can do the closed interval test for the first time this whole entire lesson. To begin the closed interval test, we need some candidates. And remember that the candidates for the closed interval test include your two endpoints and any critical values that occur in between there. Right? So to find the critical numbers, we're just going to take the derivative of our time equation. Let me just copy and paste this thing. Duplicate. And then just move this guy down here. Okay. And then probably think of that square root instead like this to the 1/2 power. Okay. All right, let's take its derivative. T prime is equal to, leapfrog that 1/2 down, and that 1/2 is going to multiply times this 1/6 that's already there. That's actually going to make 1/12 x squared plus 9 to the negative 1/2 power. Close those parentheses. And then don't forget the chain rule times 2x, the derivative of the interior part. Okay, and now on this part, realize that it's really just 1 minus 1/8 of x, right? That's what, if I divide 8 into both of these things. And so the derivative is just this linear thing that's right here. It's just the slope of it, which is negative 1/8 minus 1/8. Okay, ordinarily we do some sort of fancy factoring in order to solve this thing, but we're not going to in this case because this 1/8 surely does not have, it doesn't have any x squared plus 9 factors in it. Okay, so no worries, we're just going to write them as fractions. Cancellation crayon's going to come in handy right here, canceling out some of this stuff. Going back to that being a 6. Okay, let's rewrite this. Make it look pretty. Okay, I'm going to have an x on top And on the bottom, it's 6 square root of x squared plus 9, and then minus 1/8. I mean, sure, you could get a common denominator there if you want to, but you don't have to, because we're going to set this thing equal to 0 so we can find our critical numbers. Just separate these things. It's going to turn it into a proportion. It's going to turn into algebra 2 up in here real fast. All right, cross multiply. Cross multiply, I get 8x is equal to 6 square root of x squared plus 9. Okay, notice that both sides are even. Let's divide them by 2. 4x is equal to 3 square root of x squared plus 9. Whew, okay, we have a radical equation. To solve a radical equation, you got to get rid of the radical by squaring both sides of this thing. Okay, squaring the left, we get 16x squared is equal to, don't forget to square the 3 also, 9, and then the square and the square root, of course, cancel out. X squared plus 9. It is actually, it should neuter it, but we don't have to worry about the sign of this thing. It's always positive anyway. All right, and then maybe distribute. I have myself a quadratic equation here. 16x squared is equal to 9x squared plus 81. I don't have to worry about factoring because there is no linear term. Just get your x squared by itself, subtract over the 9x squared, which is going to give us 7 of them. 7x squared. Unfortunately, it doesn't go in evenly. X squared is equal to 81 over 7. So x is equal to plus or minus the square root of that, which is 9 over the square root of 7. You don't have to worry about rationalizing this. So just keep the square root of 7 on the bottom. I don't even care. Now, even though we have both positive and negative, we can throw out the negative because our domain is only between 0 and 8. And I'm pretty sure that this thing is in between 0 and 8. At least the positive one is. So we're going to say that our critical number, just one of them, is positive 9 over the square root of 7, just for curiosity's sake and because maybe it's going to help us figure out what this, wrap our head around where the bug is actually going to land down the river, if this one is in fact the minimum value. Let's throw that into the calculator, get an approximate number here. 9 divided by the square root of 7. .402. Did I say 3 point? Yeah, I think it was 3.402-ish. All right, so there's our critical number. Now, we haven't finished the calculus yet. We're going to now use the closed interval test on this thing. Just when you thought all of those curve sketching problems took forever. Okay, closed interval test. Remember, it just looks like a table. You don't have to worry about intervals or anything like that. And we're just looking for the smallest y value in this table. So our table is going to have some x values in it and some t of x values in it. 0. And then we've got, let's see, the square root, no. 9 divided by the square root of 7, which was that 3.4-ish thing. And then finally 8. And we want to know what is the time for each one of these things. So what do you do at this point? You're going to take each one of these time values and you're going to plug them into our time equation, not the derivative, plug them into the time equation right here. So this is a good place for us to stop this video so you can go ahead and plug and chug, as Mr. LeBeau would say, and fill out the rest of this table. We'll pick it up there in the next video.